2.
Good afternoon, Dr. Jones, fellow classmates, esteemed guests. My name is Madison Reinke. Have you ever looked at a pine cone and wondered why it took the shape it did? Well, tonight I'm here to inform you about the Fibonacci sequence and the golden ratio numbers in history and nature. I decided to do a speech on the Fibonacci numbers because of my long-held interest in nature and because of how the sequence changed the way nature was observed. Tonight we'll be talking about the history of the Fibonacci sequence, the fame and knowledge brought to the Fibonacci sequence by Leonardo Fibonacci, and the golden ratio, or how nature looks different and unorganized, but is actually very similar and organized. It would be best to start with how the special sequence of numbers was introduced. Now, the Fibonacci sequence is a sequence of numbers of where the existing number is the sum of the two numbers preceding it. The first few numbers in the Fibonacci sequence are 1, 1, 2, 3, 5, 8, and 13, and so on and so on. Now, 2 is the sum of 1 and 1, just as 3 is the sum of the pre-existing numbers 2 and 1, just as 5 is the sum of the pre-existing numbers of 3 and 2. Now, even though this sequence was not made very well known until Fibonacci talked about it in 1202, it was known long before then. There are records of the sequence being known and used in India as early as the 6th century. It was first discovered by mathematicians in India who had found the sequence by measuring the length in meters of the syllables used in words. They then discussed the numbers with Indian traders who used it to make better deals with their trades. The knowledge of the sequence was then passed on to Arabic traders who also used it to better their deals on their trades, and was then passed on to North Africa, which is where Leonardo Fibonacci would later discover it. The golden ratio, however, was not discovered until 1750, despite its very close connection to the Fibonacci numbers. While the Fibonacci sequence was known in India as early as the 6th century, it was not known in Europe at all until the 13th century. Leonardo da Pisa, now known as Leonardo Fibonacci, was the person who brought the mathematics back to the Dark Ages of Europe. He often traveled with his father to North Africa as a boy. His father was an Italian merchant who often went there to better his trading. While he was in India, that was where he first learned about the Hindu-Arabic numeral system. Now, people in Europe were still learning in Roman numerals at that time. And now the Hindu-Arabic numeral system was a really big thing because, for one, it included the number 0, which the Roman numerals did not have a number for that. So it got rid of the gap between 1 and -1. It also made the system based on groups of 10 rather than groups of 9, which it was. He wrote about this in a book called Liber Abaci, which was a book that was written and used to help traders manage their money better. Now, while it was mostly to help traders, the Fibonacci sequence was mentioned in the book. He also gave a very famous example in the book to help them understand it, known as the mating rabbits example. It states that there are two rabbits that have two babies. These babies grow up while the last pair has two more. Every time they grow up, they and their predecessors have two more babies. However, this is a very bad example because all the numbers are even numbers, and the problem is the Fibonacci series does not have the numbers 4, 6, or 10 in it, or many more numbers later on. A better example would be the bee ancestry example. Male bees only have one parent. They do, however, have 2 grandparents, 3 great-grandparents, and 4 and 5 great-great-grandparents. It matches perfectly with the Fibonacci sequence. Leonardo Fibonacci may have introduced Europeans to the Fibonacci sequence, but what they may not have known was that it had been already in Europe for a very long time. Now, the Fibonacci sequence can be found in nature and influences many parts of it. This is known as the golden ratio. The golden ratio is the ratio 1.618. Those numbers represent very good space management in nature. Many things in nature have this, such as flower heads. Flower heads have very tight flower heads, very compact, very space organized. Also, trees. Trees branch out in such a way that all the branches and leaves on it get as much sunlight as possible. Same thing with leaves on vines. They're rotated around the vine in such a way that if you were to look directly down at it, you would see every leaf. It's rotated to get the maximum amount of sunlight. Same thing with pine cones. Maximum amount of space, maximum amount of opportunity to get sunlight. Also, the golden rectangle. The golden rectangle is made from the proportions of the golden ratio. It's often seen in nature everywhere as well. For instance, the golden spiral. The nautilus, for instance, the ratio of 1 to 1.618 gets slightly bigger every time. It's also human body proportions, such as the hand to the forearm. If you were to measure it, it would be a ratio of 1 to 1.618. Because of Fibonacci, a sequence that had been known for centuries and seen constantly in nature had become a visible part of European society. Any questions?
Is the golden ratio the same as the Fibonacci series?
No. See, they're actually different. But the thing is, the higher up you go in both the Fibonacci sequence and the golden ratio, the closer the numbers are. Now, they're not quite parallel in the smaller numbers, but they're pretty much hand in hand the farther up you go until they're almost equal, which is why they're often compared. Now, do I have any more questions?
No.
Thank you very much for your time.
Yeah.